For this video, we are going to look into simplifying radicals. A radical is this. Okay? Normally we call it like a square root. We're taking the square root of a number, but that shape itself is called a radical. So when I say simplifying radicals, we're going to be looking at something like this, the square root of 4. So this radical, when there's no number here, and this number, we're going to call this an index. When there's no number given, that number is 2. And when we're looking at a square root, so there's a 2 there, we're saying what times itself is 4. And in this case, hopefully we know that 2 times 2 is 4. So the square root of 4 is 2. Same idea, we could look at the square root of 9. The square root of 9, what times itself is 9? Well, that's 3. We just simplified 2 radicals. That's really straightforward, basic. But what happens if we're not dealing with these perfect squares? So our number isn't a nice whole integer. Like if we were to take the square root of 12. Off the top of my head, I don't know what number times itself is 12. But there's a way that we can kind of simplify this into simplified form. And that's what we're looking for. What we're doing is we're trying to pull out these perfect squares like we see here. So let me show you how we simplify the square root of 12. Well, since I can't square root it, what I'm going to do is I'm going to find the factors of 12. So 4 times 3. And I'm going to square root my factors. The square root of 4, we just talked about that. The square root of 4 is 2. So now I'm left with 2 times the square root of 3. And I have now simplified that radical. The trick is, here I use the factors 4 and 3 because 4 is a perfect square. But what happens if I didn't use 4 and 3? So let's revisit. Here's 12 again. Factors of 12, I could have used 2 and 6. And if I square root these, there's no square root of 2, and there's no square root of 6. So now what do I do? All right, 2 is prime, 6 is not. So I'm going to factor 6 to 2 and 3. All right, so now I'm left with the square root of 2 times the square root of 2 times the square root of 3. Here, my square root of 2 and my square root of 2, I can multiply those back together, and I get the square root of 4. Now I have a perfect square. The square root of 4 is 2 times the square root of 3. Same solution, but we started at a different point. That's totally cool. It doesn't matter because we're always going to end up in the same place no matter what factors we start with. Another cool thing just to talk about, when we multiply a number by itself, so here I have the square root of 2 times the square root of 2. Multiplying a number by itself is squaring that number. So the square root of 2 squared, that reduces, and I'm left with just 2. So when we're looking for the square root, we're looking for these groups of 2 that we found right there to be able to multiply those together to get rid of the radical. We're pulling out those perfect squares or these repeats like we saw in this example. All right, let's take a look at another number here. Now, let's take or simplify the square root of 18. Again, there's a couple different paths we can take because there are more than one set of factors for 18. But if I start out and I say this is 9 times 2, and I square root them. The square root of 9 we figured out was 3, so this is just 3 root 2. I'll show you another option. Factors of 18, 3 and 6, and I square root both. 6 is composite, so I can factor. 3 is prime, so that one's good. So then I have 6, its factors are 3 and 2. So now I'm left with the square root of 3 times the square root of 3 times the square root of 2. Square root of 3 times the square root of 3, well, that's the square root of 9. and the square root of 9 is 3, and then I multiply to my root 2. Okay? Awesome. I'll give you one more. I want you to do this one kind of on your own, so you can put pause and then come back and check it. So my last example here, I'm going to change it up a little bit, and I'm going to put a coefficient out front. So this is 8 times the square root of 75. So you can go ahead and hit pause, see if you can work through this one, come back and check. So this 8 out front, it just becomes part of this list at the end. So for now, I'm just going to ignore it. And I'm going to look at 75. 75 is 5 times 15, and I square root. 15 is 3 and 5, and I square root. Sometimes it's helpful to go back and cross out the ones you factored, so you know you've already used them. They're done. So at the end, my list, I have 8 times the square root of 5 times the square root of 5 times the square root of 3. So these 4. 1, 2, 3, 4. The square root of 5 times the square root of 5, that's the same as the square root of 25, which is 5. So this is 8 times 5 times the square root of 3. So there's 40 root 3. Okay. And again, this 8 out front, it's just a multiple. So at the end, I just take that 5 and I times it by 8. Good luck. Practice hard.